In our lab, over the past few years, we have been working on image and video compression techniques. However, in this talk, I am going to introduce a special kind of compression where you actually have objects in very high resolution and rest of the parts you absolutely neglect. So, we all know what is the resolution of images. An image is made up of pixels. The higher the number of pixels, the higher is the resolution. And the lower the pixels, the lower is the resolution. So what do we want to do in our research, taking into consideration the resolution? Here, we are considering the fact that we want to capture some of the objects in high resolution and some of the objects in poor resolution. Here we can see an image of a kayak with 2 persons at Lake Michigan, and we have captured the image of the person and the kayak, and the rest of the part, which you can see in a very low resolution, is evident in this image. Now, for the video compression technique, the frame rate and the resolution is quite important. The resolution dictates the quality of the image, and the frame rates dictates the frames per second. So, for a constant bandwidth process, we have to optimize between the frame rate and the resolution. Now, how do we do that? We have gone for an adaptive learning-based imaging framework, which consists of 2 components. The first is a host, and the second is a chip. Now, what is a host? A host is nothing but a computer with very high computational power. So, in short, it can be a GPU or a server, like the AWS. And secondly, we have a chip. So what is a chip? It's nothing but a camera or an imager. Now, what the host of the computer does is that it predicts a Quadtree structure and transfers it to the chip. And the chip acquires data based on that Quadtree structure. Now, what is a Quadtree? For an image, it can be a very big block or a small blocks. Now, image can be segmented into squares, and each square can be further be segmented down until you reach the minimum of the square. Now, the number of small squares you have, the more higher the resolution of an image is. Now, this can be represented in a form of a tree, as you can see. The tree structure, as you go down, the finer the squares are, and so the higher the resolution. So what does exactly an image look like? As you can see in the image, which is nothing but a military image, there are several tanks and vehicles which are moving. So we want to capture this. So as you can notice, in the edges of those military vehicles, we have a very fine segmentation, and hence we capture more data, and thus the resolution in the edges are very fine as compared to the rest of the images, which is a kind of a blurry. Now, what do we do exactly with the Quadtree? Based on the reconstructed frames which are available on the host gives a prediction for the next Quadtree, and then the Quadtree is passed to the chip. The chip does then do the acquire of the data based on the Quadtree and also corrects it in case there is some error. Now, how does exactly the host do a prediction? Now, based on the image captured by the chip, a host takes into consideration the reconstructed previous 2 images, and it does a prediction on those 2 image frames. Then it does an optimization based on the predicted frame and the past frame, just immediate past frame. And then it proposes an optimized Quadtree structure. This Quadtree structure then goes to the chip, where it captures the image based on the Quadtree. So, what is the prediction scheme which we are currently using? As of today, we are using 2 schemes. The first one is a motion-based acquire of the data based on the Quadtree, and the second is the prediction of objects. Suppose you have humans which you try to focus on, and there are cars on the scene, and you want to focus on the humans. So you give priority to the humans and do higher data acquire in those areas, and you neglect those regions where there is humans or you don't care about. Now, running our algorithm, we have seen this kind of a result. When you use a camera with uniform resolution, the picture quality has uniform resolution throughout. However, with our technique, you can just focus in a very optimal way on a person. For instance, the pedestrian, as you can see in the center of the frame, has a very high resolution and other parts is kind of blurred. So this is the beauty of our technique, which we have currently tested. Now, what are our future goals? Here, it's a very high possibility of implementing our technology to a lot of applications. However, we would like to propose the data acquired based on events and anomalies, mostly for the military applications. Secondly, we would like to have an adaptive quadtree structure rather than a fixed quadtree structure that we are currently having. And finally, we would like to have an octree-based segmentation which takes into account the time and the space, and hence the impact of this technology would be very vast. We hope that in the coming days we would be able to capture images in commercial cameras with high resolution in particular objects based on a computational structure which is which adapts itself to user preferences and the as well as the scene in dynamic fashion. And thus, in the end, we would have a video which would be both compressed and optimized in the bitrate optimized fashion. Thank you.